Welcome back. This is the lesson recording number 3 for IM2 distance learning, September 21st, 2020. Where we've left off was the first card on the rotation number 1 card, and that you were given the rule. Okay, now this time you're going to try to rotate this triangle first and then figure out the rule. Okay, how do I do that? Probably the easiest way is to draw an L. So if I was to draw an L for each of the points, so I draw an L, so there was 2 to the right and then 3 down. That's what that coordinate was. So now try to rotate this L. So then it just becomes counterclockwise. It will look like this. Okay, so then this is going to be my M prime. M prime, and it's going to have the coordinate of 3, -3, -2. Okay, all right. So then what about B prime? Let me get a different color. So for B prime, again I draw an L, and this time it's going 4 to the right and then 7 down, right? So if I rotate this L, see if you can picture this L being rotated clockwise, so it will look like this, it will look like this, so eventually it will look like this. So where it is 7 across here, oops, and then 3 down, or 4 down, 7 across and 4 down. That will be my B prime, and it's going to have the coordinate of -7, -4. Okay, and then lastly, let me do it with purple. This point is going, you can do a L looking like this, or you can do a L looking like this. Okay, so that's my L. So that's going 6 across and then 1 down. So if I was to rotate this, it will be 1 across and 6 down. So it's going to be this point, and that's going to be A prime, and that's going to be -1, -6. So now that I've drawn my triangle, I can draw my lines to connect the dot. Okay, here is my rotated triangle counterclockwise by 90 degrees. Okay, so if I was to write down the coordinates, B prime, he had -7. B prime had the coordinate of -7, -4. Okay, and M prime had the coordinate of -3, -2, and A prime had the coordinate of -1, -6. Okay, so now look at the numbers. How did the numbers change here? Okay, so -4, 7 became -7 and -4. -6 and 1 became -1 and -6. So the x and y's got swapped, didn't they? Okay, so I can write here that x and y got swapped first of all. So instead of x became y, and y became x. What else? Did the signs change at all? Well, 7 became -7. -1 became -1. 3 became -3. The x's stayed the same. Okay, so the y became -y. Okay, like so. So x became negative version of the y, and y became the x, and that will be my rule. Okay. All right, then finally you were supposed to match each graph to each transformation rule. So if you see x plus 3, y minus 2, what is the transformation do you notice? Okay, it's translation. It's a translation of 3 to the right and down by 2. Okay, 3 to the right and down by 2. And the original is the blue. I'm sorry, no, original is the black, and the blue is the transformed. Okay, so I would say this goes with this. Okay, and then I will move it over here so that it's not blocking anything. Okay, so then what about x becoming plus 1 and plus 4? That means it's a transformation again. So we're looking for transformation 1 to the right and 4 up. 1 to the right and 4 up. So that's this one. So I am going to put that over here. Okay, x and y Okay, so let's do another transformation and translation. 6 to the right and 6 up. 6 to the right and 6 up. 6 to the right and 3 up. I'm sorry. 6 to the right and 3 up is this one. So I'm going to move that here. Okay. Now I have this. Y is becoming y plus 5. I think this is an error here. Okay. Okay, so now we have 1, 2, 3, 4. All right, so what's happening here? X is becoming the same, but y is becoming opposite. Okay, so y is becoming opposite. That means it's a reflection over the y-axis. Okay, and this will be the reflection over the y-axis. And here, am I missing some cards? Yeah. Okay, no. Y, x, and y x is becoming opposite and y is becoming its opposite as well. Okay, and that's actually reflection over the xy, y plus x. All right, so y is becoming is subtracted by 1. So this is actually technically not quite right, but let me just put it in there just to make it go. And okay, so what about this one? Is that a transformation? No, it's not, because the shapes are actually being changed. No, it's a mirror image. It's a reflection against y is equal to 3. Okay, so it's none of those, and it is none of these. Yeah, I've actually made a few corrections to my Desmos cards. Okay, so now common transformation rules. Let's just sum up what we've learned. So you should be taking notes right now. What do we discover? So translate right by A up by B would give you X is going to get added by A, and up by B would give you Y is going to be added by B, whatever B is. Okay, so this is right by A, up by B. So if it's left by A, then you're going to subtract. Okay, or if it's down by, say, 3, then you're going to subtract 3, not add 3. Reflecting across the x-axis, the x stays the same, but the y will become negative version of it. And reflecting across the y-axis, the y will stay the same, but the x will become negative version of it. And then rotating 90 degrees clockwise, x and y, they will swap, but as well as the x, where it becomes y here, becomes a negative version. And rotating 90 degrees clockwise, x and y again will swap, but the y will become negative version of it. And then rotating 180 degrees, x and y will swap, and both x and y will become negative versions of it. Okay, so thinking about rotating counterclockwise or clockwise, like I've shown you the drawing, try to see if you can draw an L. Okay, so if I was to draw an L here, so it will look like if I have a point right here. Okay, if I have a point right here, okay, I will try to draw an L to the origin or wherever the point of our rotation is, and then rotate that L. If I'm doing clockwise, I am going to rotate that L to look like this. Okay, so this L becomes looking like this. Eventually, when you keep doing this, it becomes that Nazi symbol. Okay, and I am certainly not promoting Nazi or anything like that. This just happens to look like that. Okay, so if I was to rotate this L, it's almost as if I am rotating it, the whole graph to the right. Okay, so that point that was here, it's hard to demonstrate. So while as in rotating counterclockwise, you are rotating the graph towards the left. Okay. Alright, so using transformation rules. So answer in private chat. If you are given this triangle ABC as defined as these 3 points, which triangle below is the image of triangle ABC when it's rotated 90 degrees counterclockwise about the origin? Okay, so you can use the rule to figure out which is the correct one. The answer will be in 3, 2, 1. It's when you rotate 90 degrees counterclockwise, the rule is x and y swap, and the y becomes the opposite. So x and y swap, so it becomes 2 and negative 3. And the y becomes not 2, but negative 2. So it's going to be negative 2, positive 3. Negative 2, positive 3. Okay, so we're looking at these two options. And then 4 and 9. So it will become 9 and 4. And instead of positive 9, it will be negative 9. Okay, and then C will be opposite, and the Y will become negative, so it's going to be A. All right. So to close, as far as to end the lesson, please enter the rigid transformation algebra rules. Also, if you have not done so, there was a link to team preference Google form. Please fill that out. That's it.